Hello. In this video, I will explain the new workflow for the multitask machines. Okay, we will machine the part like this one, and our machine has two spindles, left spindle, right spindle, and two channels, milling head on the top and turret head on the bottom. Okay, beginning is the same like in version 14. I can create, for example, lathe facing, simple operation, and calculate it. After that, I would like, for example, create lathe hole machining. Set this one and define and run. One moment. Then I calculate this operation. I don't calculate the links between the operation, so I run it without links. Okay. The next, I would like, for example, to make roughing. And that's enough for the left side. And so, because I will work with two copies of the same part, I need to make the parts. Create structure part. It's the part in the left spindle. I can even rename it left part. And I create another part. What is important here? It will be another copy of the same part. So the part of the previous operation, it's exactly the same. The workpiece is the machining result, but the location is the right spindle. So it will be here. It will be placed here. And we will have new origin also. Here. Okay, we have created the new part. So if I will check the workpiece, you can see that the workpiece for this part is the result of the all previous operation we already made. So for the right spindle, I will rename it to the right part and do the same operation. For example, lathe facing. For the facing, I will select this. I can disable this job assignment, set the correct tool, this one. I will use this tool and okay. I will create deroughing. Again, same tool. And the job assignment, change the direction, edit a little bit. Okay, so made the roughing, and the last operation, for example, I will create 2D contouring to machine this profile. Okay, for 2D contouring, I will use the tool mill spindle. offset, it will be axis 0, axis this one. Create new tool, for example, 10 millimeters diameter, 50 millimeters length, cylindrical wheel, and air hung. Okay, that's good. And define the job assignment. This curve, this bottom level, this one top level, and side of machining, and this one, and offset. Okay, I can run it. So I can go to simulation and check the result we have. So right now it's calculated without approaches. Facing, drilling, roughing in the left spindle, and same with the right side. Okay, and okay, for the last operation I need to switch on the polar interpolation. Okay, I think right now that is good. And another very important thing. So I would like move the part from after the machining. I would like to move the part from the left spindle to the right spindle, and to do it we have the new operation here in the auxiliary, MTM takeover. This operation takes the new place from the next part from the right and move the current workpiece left to the next to the right. That's all. And also I would like to remove the ready part from the right spindle. I will use pick and place operation for that. I can even rename it to remove ready part, and there is the remove part. It's important for the simulation, so I added all these operations created. That's okay. So the next stage, right now we prepared the total machining sequence for the part step by step, and the workpiece or the part will be moved from the one operation to the next one. But because we have two copies of the part, we need to reorder the machining process. So I switch on this sequencing mode and reorder the operation how I would like to machine it. Okay, facing is the first, it's okay for me. Drilling also, but after that I would like to make the facing in the right spindle, roughing in the right spindle. After that I would like to make roughing in the left, and takeover will be located after all operation. So machine face in the left spindle, hole in the left spindle, face in the right spindle, roughing in the right spindle, roughing in the left spindle, contour, remove part from the right spindle, and move the workpiece from the left to the right spindle. So right now I define the order of machining, and after that I can calculate the links between the operation. Run set here, run calculate links. So we have the lines here, and you can see the lines here. And right now we can go to simulation, for example, and simulate it in the sequencing mode. So how it will be machined without synchronous machining. Okay, let's check. Facing here, it's okay. Drilling. Okay. Facing here. Roughing. After that, roughing here. Okay. And after that, profiling here. It's better. And remove. Okay, we have collisions. We have collisions when make the takeover, and for the 2D contouring, I would like to enable deleted chips. And for the before I will make takeover, I would like to move this position to the left side. And I would like to set B-axis in this position, and same with this one, B-axis here and here. Okay, I hope it will work good now. Recalculate everything. After that, switch on. Calculate the links. After that, go to simulation and check again. Facing, drilling, roughing, another roughing, contouring, move. Looks good, but it's still not the actual process, because we need to define the multi-channel mode. Okay, if I try to run it in this way, we will see a lot of collisions. Let's check. So together, and the first thing I would like to do is to define the synchronization point. I would like to start drilling. Only after we finish the facing. So select this one and add the synchronization point. The next, let's check. So it's wait until we facing, and after that, and so, and the next collision again. So I would like to wait the end of roughing before contouring. So write a deroughing, go to the end, this one, and beginning of 2D contouring here. Add the synchronization point. The next step, I would like also start the takeover. So last two operation here. Only after that we finish all the machining. So before approach and waiting for the end of the this one and takeover approach and add the. Let's check the simulation. reset workpiece and try to do it. Waiting here. Okay, it wait quite long time, so we can reduce the feed rate for the drilling, for example, to optimize the tool lifetime. Okay, after that profiling and 2D contouring, and in the end finish this one and take over. Okay, we can see the collision, and okay, to remove the collision, I need to, for the last operation of the turret head, I need to define the correct tool change position. So the last operation, this one, left spindle, are deroughing this operation, and I define the tool change position. Custom, but this set will be something like that. Okay, and for the drilling operation, I can even reduce the feed rate because we had enough time in the next. So not spindle, but work. Okay, it's okay. Again, recalculate everything. Switch on sequencing, calculate the links, go to simulation, check, and right now set and simulate it. Waiting. Drilling here. Waiting. Yes, this one. And take over with another. That's all. So the part is ready. I can even demonstrate you more complex machining of this part that contains more operations. So many operations here, and it will look something like that. Collision. Okay. So I would like to repeat again the main stages of the workflow. First of all, you need to develop the process in the simple way for the first part and for the part in the second spindle. After that, you need to reorder the parts in the sequencing mode, and after that you need to add the synchronization points and check everything in simulation. So the simulation can work in 3 modes: simple mode, sequencing mode, and the synchronization mode, and you can check your process in every this mode. Thank you very much for your attention.